Hi, I am Muhammad Noor Malfinman bin Rosaizan. My student ID is 08DP21F1096.
Hello, my name is Muhammad Nur Rahman and my number matrix is 08DP21F1111.
My name is Muhammad Shakiri bin Muhammad Nazir and my matrix number is 08DEP21F1094.
Hello guys, Assalamualaikum. My name is Muhammad Ilmi Hakimi bin Muhammad Fauzi and my number matrix is 08DEP21F1091. Okay, today I want to talk with you about vector and scalar. Okay, now I want to talk with you about introduction for vector and scalar. Okay, vector and scalar. A quantity that has magnitude but no particular direction is described as a scalar. A quantity that has magnitude and acts in a particular direction is described as vector. Scalar quantity. Scalar quantity only have magnitude. This is size. And then vector quantity. Vector quantity has both magnitude and direction. Example for vector. For example, 11 ms and 15 ms at 30 degree to the horizontal are both vector quantities. Vector quantities include displacement, velocity, acceleration, force, weight, and momentum. And for two scalar, for example, 11m and 15 ms are both scalar quantities. Scalar quantities include distance, speed, time, power, and energy. Thank you.
I'm gonna talk about the application of vector and scalar. The application of vector and scalar is there are two types of vector, that is scalar dot product. The formula is a dot b equals to a1 b1 plus a2 b2 plus a3 b3, or a dot b equals to a bracket and b bracket cos tangent. If you see on the right, like shining a light to see where the shadow lies, that is the example for vector scalar dot product. And if you look on the bottom, we take component of a that lies alongside b here, as you can see on the image. Next is vector cross product. The formula is a cross or times b equals to bracket a bracket b sin tangent. With your right hand, point your index finger along vector A and point your middle finger along vector B. The cross product goes in the direction of your thumb. If you see on the image, it shows how you can do with your hand. The index finger with finger along vector A and the middle finger along vector B, while the top is A cross B times B. Next is vector in gaming. This is the example of use of vector. In games, vectors are used to store positions, directions, and velocities. The position vectors indicates how much time it will take or how much force we should give, and the direction vector indicates in which way we should apply the force.
Next, I'm gonna present about mathematical solution. So the first question is, a ship leaves its home port expecting to travel to a part 450 km due south. Before it moves even 1 km, severe storm blows its 150 km due east. So how far is the ship from its destination? In what direction must it travel to reach its destination? So the solution is, you draw a triangle and you label it. Then you use the formula of theorem Pythagoras, which is c square equal to a square plus b square. So you will get square root 150 square plus 450 square. You will get square root 22,500 plus 202,500. if you plus it, you will get square root 225,000, and if you calculate it, you will get 474.341 kilometer. So if you want to get the degree, you use tan theta equal to 450 divided by 150. You will get inverse tan bracket 450 divided by 150. You will get theta equal to 71.6 degree. So the ship must travel at 474 kilometer in direction 71.6 degree of west. For the next question, we need to find the perpendicular to both vector A and B. And the second question, we need to find the angle between two vectors. So the solution for I Roman, we need to find the perpendicular using a cross product. So you arrange the vector A and B like you using the determinant, then you calculate using the determinant formula like AD minus 2BC, and we'll get negative 5i, negative 9j, negative 8k. So for the second one, you need to find the angle. So if you want to find the angle, you use the dot product formula, which is a dot b equal to a1b1 plus a2b2 plus a3b3. So you will get negative 8, but then you need to find the magnitude of a using like theorem formula. So you will get square root 26 for A, and you will get square root 9 for B. So if you want to find the angle, you need to use the formula cos theta. So if you derive the equation, you will get theta equal to cos inverse bracket A dot B over magnitude A and magnitude B. So if you calculate it, you will get 121.53 degree. Thank you.
The conclusion in this topic is when vector is used extensively throughout physics and engineering, mostly with regard to electrostatic fields, gravitational field, and fluid flow. When taking the derivative of a vector function, the function should be treated as a group of individual functions. If you were to take a cross section with the curve perpendicular to any of the three axes, you will see the graph of that function. So, the domain of vector value function is the domain that satisfies all the component functions. It can be found by taking the intersection of the individual component function domain. The vector value function can be manipulated in the same time way as a vector. So, they can be added, subtracted, and dot product, and the cross product can be found too. So vectors are very important in our daily life and especially in engineering. So we know that vectors are used in engineering to represent quantity that have both a magnitude and direction. So many engineering quantities such as forces, displacement, velocity, and acceleration will need to be presented as a vector of our analysis. So I think that's all for to me. That's all from us. So thank you.